A gas with empirical formula CH2 effuses 75.6% as fast as oxygen under the same conditions. What is the formula for that gas? So if we recall back to what we know about grams, the grams relationship, we know that the rate is going to be proportional to the square root of 1 over the molar mass of that gas. So in this case, what we would have is a relationship between some rate of A over rate B is simply going to be the square root of rate of the molar mass of B over the molar mass of A. Now, we don't know one of those molar masses, but we do know the molar mass of oxygen. So we have some information here, and we can find rate information. Now, we can work with all of this as best as we can, but we have a lot of unknowns to work with. How do we best deal with this 75.6%? Well, we're relating the rate at which some gas effuses. So the rate of that gas times 75.6% is going to be equivalent to the rate of oxygen, based on the way that the question was worded. It says that the gas effuses 75.6% as fast as oxygen. So the rate of oxygen is going to be equal to whatever the gas is times 75.6%. So what I can do is I can figure out a ratio between the rate of the gas versus the rate of the oxygen. So I can say that rate gas over rate oxygen, which I already know the molar mass information will be molar mass of oxygen over the molar mass of our gas. It'll be equal to 75.6% or 0.756. Because all I'm really doing is I'm taking that Rg times 75.6% equals RO2. I'm just dividing the rate of oxygen by both sides. And I'm relating that back to that rate versus molar mass relationship. Now, what I can do to one side, I will do to the other, so I can flip this all up if I need to. So I can plug in what I do know and what I don't know. I can take the square root of both sides. So I can take the square of the square root and do the square of the 0.756. So the molar mass of O2 over the molar mass of our gas is 0.756 squared. And since the molar mass of our gas is unknown, I'm just going to call that X. Molar mass of oxygen is 31.998 grams per mole. So my X value, the molar mass of my gas, is going to be my molar mass of oxygen, 31.998 grams per mole. Divide that by the 0.756 squared. And I get a molar mass of my gas equaling 55.98597 grams per mole. But the question wasn't, what is the molar mass of this gas? The question is, what is the formula of this gas? So if we recall, we know what the empirical formula is. It's CH2. And this has a molar mass value of 14.026 grams per mole. So I could take the molar mass of my newly discovered gas, divide that by the empirical formula to get some whole number value. So 55.98597 grams per mole. Divide that by 14.026 grams per mole, and I get a value roughly close to 4. So I'm going to take my empirical formula and multiply those subscripts by 4. So C1H2 now becomes C4H8. So the key to this, is not only recalling what the grams proportion is, but also figuring out how do I best use that 75.6%. It's the relationship between the rate of our gas versus how fast O2 or the rate of O2 is going.